But excuse me. One of the things I wanted to start with is just kind of reminding us of where all the pieces and parts go. So as you go through all of these things from before, remember, everything stems from being a parallelogram. So we had this giant family tree. Thanks. And we kind of drew it up with all of our markings to show what everything happened. I know it's a hodgepodge mess, but that's basically everything that we've talked about was already done into that one giant picture. We've looked at this before, so this is anything different. And what we're talking about is we're going into this further, and it's basically just a family tree. And every single tree that we talk about that is a parallelogram has all the same properties, but something else. For example, we all know a rectangle because of what? Well, yeah, duh. What makes a rectangle a rectangle? About the fact that it has right angles. I didn't hear you, sorry. So what makes a rectangle is that it has the 4 right angles. It only has a couple of special parts. It has the 4 right angles. And the other thing that happens is that their diagonals are congruent. Okay. So rectangles has the 4 right angles and diagonals that are congruent. And when we go back and talk about what the rectangle is in terms of the parallelogram, remember parallelograms, their diagonals bisect each other. So if I've got the 2 diagonals that are congruent, if you bisect them, you get 4 chunks that are all the same. All those pieces wind up being the same. And then basically what will happen is we get into this even further, you'll notice that this creates isosceles triangles inside there, doesn't it? So you'll get 2 sets of isosceles triangles inside rectangles. And we'll be able to use the properties of that for base angles and things like that. So it's really, really easy. 2 things add up to equal 90, we call them what? Complementary. Complementary comes before supplementary in the alphabet, so 90 comes before Roman 80. You'll see a lot of that in complementary stuff as well. It's pretty darn easy, and I know you guys have all seen this. The rhombus. 4 congruent sides. Diagonals that are perpendicular. I'll list this out here. And the last part of that is the diagonals bisect the angles. Okay. So what happens in all of your base angles, these 2 are going to be the same, those 2 are the same. Okay. So the rhombus has 3 things. Again, this is nothing new. I know all of you guys have seen this at some point in your lives. You might not have just done it with some of the algebra. That's about it. Like I said, it's just a really nice little leftover topic to finish out before break. It's not a lot of brain power. When you see right angles, that means you're probably going to have to use what sometimes? What's that thing that we keep using that even though we've never been taught how to use it? Yeah, Pythagorean theorem. Yep. You'll see Pythagorean theorem. Yep. You'll see Pythagorean theorem quite often with these guys, with both this one and with this one. I know that the homework tonight, I've got there's a couple of parts on there that you don't know how to solve for, because I'm using a different worksheet, because I think I've mentioned this before, this chapter used to come after we did trig, so you can do some stuff with it, but no big deal. And then the last one obviously is the square, which has everything. The square has all the parts of a rectangle and all the parts of a rhombus. Excuse me. Thank you. Diagonals, excuse me. Oh, the diagonals bisect those angles. If it bisect a 90-degree angle, what angles are made? So these all become 45 going all around. What am I forgetting? Oh, perpendicular diagonals forgot. And in that square, those 45, we call those 45, 45, 90, bless you. Oh, the thing about the C selector, I'm sorry. You had that.
I was, but you said it over.
Well, one of the things that happens with squares is that you get 4 triangles that are all 40, what we call 45, 45, 90s in there. That triangle, that 45, 45, 90, is one of the triangles that's the basis of all trigonometry. I don't know if you guys ever noticed or saw anybody in an Algebra 2 class last year. They had something called the unit circle. Or if you had a brother or a sister or something like that. So that's 0, 45, 90, 135, 180, 225, 270, 315, and 360. All I did was just went up 45 degrees all the way around. You okay with that? What happens here is, well, let me ask this. When you put something on a two-dimensional plane, you guys know what I mean by two-dimensional plane?
No.
An XY graph. Do you guys agree that there's some coordinate? What happens with this is that this coordinate reflects itself, just changes the X value, changes the Y value. Goes back this way, it comes back up, and what does that basically make? It makes a square. Okay? It actually makes a square. Those points, those ordered pairs there, wind up being points on a unit circle. Okay? And you get to do all this trick stuff off of that. Then you'll have values here, here.
Yeah, I remember that.
It keeps coming back and around. But it's just one of those things that, you know, you'll see it eventually, but why this stuff is important kind of starts from this idea of the 45-degree angle. Also, one of the things you'll see do you guys agree that a 45, 45, 90 triangle is isosceles? It's got 2 base angles that are the same, which means the 2 side lengths have to be the same. Now, if I say that this is 5, what does that have to be? 5. Okay. How do you solve for the hypotenuse if we know the two legs of a right triangle? Okay, so you said 5 squared plus 5 squared equals c squared. Well, what's 5 squared? 25 and 25 is how much? 50. In your calculator, yours won't work. In your calculator, the multi-views, take the square root of 50. Yeah, buddy. You're going to get this root 2 thing. Yes, sir? No decimals. No such thing. What's going to happen is that you get these special triangles. And whatever the side values are in an isosceles right triangle, if it's 15 and 15, this side will be 15 root 2. If it's 115 and 115, it'll be 115 root 2. And so on and so on. There winds up being this special pattern that occurs. We go all through all this stuff later on in second semester with some of the right triangle things that we do. But the reason that this stuff works is because of the isosceles stuff. So when you start to see, when you start getting some of the problems later on, if you do have to get the Pythagorean theorem, if you start seeing root 2s a lot, it's okay. And that's fine. And that's what we're going to leave it in that radical form. It's called an exact answer. You guys have heard that before, right?
Yeah.
Exact answer versus decimal. We like to keep things in the exact form. It's easier to work with. Okay? So, let me show you some examples. Like I was saying, it's a lot of solve for x's and y's today. That was really loud, sorry about that. It's a lot of quick solves for x's and y's. Identify what kind of shape it is to go with it. And try out from there. What shape does that have to be? If it was a square, what would that angle have to be? 90. So yeah, it's just got to be a rhombus. But it being a rhombus, then, what do you know about all the sides? They're equal. So algebraically, what do you have to do to solve for x? Exactly. So they equal each other. It's also kind of nice to have tick marks on the side of this picture, but pretty easy to figure that out. The angle, you have to do a little thinking. Pick on the little guy. Really, really, really easy math today. Yeah. Now, angle P and angle Q, they're next to each other in a parallelogram, aren't they? Means they have to equal how much? 180. So they have to be supplementary. So I can do one of two things. I could say that 12y minus 1 plus 97 has to equal how much? 180. Or could I just figure out what the supplement is?
Yeah.
What's the supplement of 97?
All right, when you finish it.
Yes, sir. 83. Very good. Or you can just do that right away. Either way, it's going to work. So you can figure out what the supplement is, knowing that that has to equal that much, or just put them together if they have to be supplementary. Math is going to still math. If you math it correctly, you'll be fine. Go. No, I know. It's a lot to ask. But you'll be okay. These are all crazy days. Right? Hold on. ¿Cómo estás? Bien. Gracias. Tienes 9 lunes para spring breakup.
Quedan significa dinero. Quedan 9 lunes para vacaciones.
Sí. Es muy importante.
Oh, muy bien. Pero son 1 día y medio para la Navidad.
Sure.
Un día.
Or if you look further ahead, your sight's further out there.
9. 9. Wow.
I know.
I think I can survive this. So
It's just nine.
But it's really like this, I mean,
It's
everything,
yeah,
real life, real calendar.
real 9 fun days get from this week.
All
What do you
right,
got?
I know Mia. I need a Mia.
I think she's trying to hide.
She has already started. Nice try.
But hey, you were on time today.
Good job, Mia.
All right.
Man, I wish I could take that.
So if that's a square, with just that one piece, what JG is 15. Yeah, you can go through and you can label every other segment that's in there, and you can label every other angle that's in there as well. Just because you know what a square does. So if JG is 15, what is JH and JE and JF? They're all 15s. Okay. Which makes all of these base angles here. Yeah, I'm sorry. Yeah, you were right by when I said base angles, but all the smaller angles with 45s. Makes those 90s. Guys, what are your outsides going to measure? If your legs are 15, what's your hypotenuse? 15 root 2, good. Hey, do you think there's a reason why I used 15 earlier? I don't know if it's brilliant. It's just a square. I'm sorry it was so elusive. You know, those squares are slippery because they can just bounce all over the place, you know. What's up? Remember what you've got here. If I draw this back out, these are both 15s, correct? A squared plus B squared is C squared. So in my calculator, I type in 15 squared plus 15 squared, and I get 450. Take the square root of that, and you get 15 root 2. It's quite literally just using the Pythagorean theorem, okay? So on this sheet here, ladies and gentlemen, you will be able to do all of it except for 2. So you may skip 20 islands in there. No, I'm kidding. You can let it in. So on here, you should be able to do everything. Those last 3 and number 20. They have a little bit more trig stuff thrown into them, so we don't have to worry about those. But everything else is real quick, okay? So remember, any of you guys that were out, when you're taking out that quiz, really all you have to go by here is your family tree. Remember, we have parallelograms. In a parallelogram, we know that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect, What did you do?
I'm good.
Kind of.
I got
He definitely didn't fix it.
I got this.
He didn't do it. He was like, I'm just.
Yeah, I did.
So when we come back from there, we'll get our.
Yeah, I have to, we're still trying to put that together. I know that Seb and Fontana have been trying to put in some new pictures and things with some stuff. So I don't know if they'll have it done tonight or tomorrow, but whenever, I'll make sure, I'll just make a PDF of it and just email it out too. But yeah, so if you guys were out doing the stuff, basically it's all just this, it's a little family tree. And that's kind of what you were just writing down a second ago as well. Okay? This shouldn't be very
I'll
difficult.
send it to you.
Uncle.